Hello everyone, welcome back. Today we're going to be learning how to random numbers, which is super important in a lot of video games. A lot of video game design really hinges on randoming numbers, and we'll simulate rolling dice from there. We'll code rock, paper, scissors in a separate video because it's going to span over multiples. Let's get started. In Java, there's actually several ways to generate random numbers. The math class, for instance, supplies a method. It's kind of tricky. I'm not a big fan of random. What I'm going to teach you is the random class. It's a little bit easier to use in my opinion, but we're going to see there's 3 steps. It's going to feel like scanner in some parts. Let's take a look. For one thing, just like scanner, we're going to have an import statement, and just like scanner, you're going to need to construct an object, in this case a random object, and then we'll end up generating a number. So like scanner, random is part of the util package. You will need to import it before you can use it. Right, so here's our import statement. That, of course, appears at the very top of our class, right? Even outside of the class, the very top of our file, maybe I should say. We're going to import java.util.random. Think of these things as folders. So there's a Java folder, and then inside that is a utility folder, and then inside that is where we can find random. And like scanner, an instance of random will need to be constructed in order to invoke random methods. So we create our random object after that, right? Notice over here, this is actually variable declaration. We're creating a variable called rand of the type random, right? This is really not that different from saying something like integer x or double z. And we're setting that equal to a new random object. Don't worry too much about what's going on here, but this is very similar to scanner. And then we're going to have a next int method, which will return a random int between 0 inclusive and the specified int exclusive. Okay, for example, if we said next int 3, we're going to get a random number in the range 0 to 3, right? So 0 is included in that, all the way up to 3. This, of course, means exclusive. So notice that 3 itself is not in our set. Okay. How I like to think about this is number of possibilities, right? I have 3 possibilities starting at 0. Okay. Let's kind of demonstrate this, and I'm going to pull up IntelliJ in order to do that. I'm just going to maybe like open up a recent little test program, maybe. Let's do a new one. This is going to be really short. You can just watch if you would like. You don't necessarily have to create a project, that sort of thing. It looks like I ended up finding one that already existed. Let's open this up. Ah, yeah, that's where I was playing with some mod stuff or some logical operators. So here I have a main method, and what I want to do is implement random. There's 3 steps. The first one is my import. Right? I need to import java.util.random. I know some of you probably just cringed just now because you kind of know from our experience with scanner, we can skip straight to step 2. All right, so I deleted my import statement. I'm going to skip straight to step 2, which is creating the random object. Right? I use the IntelliSense to complete this word, and then hit enter. And that caused IntelliJ caused an import to occur. So I can just skip straight to, and basically step 1 gets taken care of. So I'm going to create a random object. Really, the left-hand side is a variable. I'm creating a random variable. I like calling it Randy, and that is a new random. Okay, nothing really needed in the parentheses here, right? When we were talking about scanner, we needed some arguments to get passed in. And that was because there's a differentiation, right? We could actually use the keyboard, which is what we traditionally use with scanner, or you can actually use scanner to read from a file. And so you basically, whenever you're creating your scanner, you have to tell it in advance what you plan on reading from, right? In this case, it's a random object. It's going to function the same way every time. No need to pass in arguments. Now, step 3 effectively is actually randoming a number. I have created my random object, and I'm saving it into a variable called Randy. So if I want to use a method that belongs to random, I can take Randy and do dot, and what I'm looking for is next int. This is going to ultimately take an integer. Notice it technically doesn't have to. I'm not going to comment on that, but let's say that like I put a 10 in here. Okay, I'm going to right click in free space and tell my program to run. That's all three steps of random, right? We've imported, we've constructed our random object. I'm calling the next int method by going through Randy. What happened here? Well, this method is returning a random number in the range 0 to 10, inclusive, exclusive. All right, so 0 is one of my possibilities. 10 is not. However, there are 10 different numbers, 10 different integers in that range. What I am highlighting is an integer. This returned, right, or spit, it produced an output, and it's just sitting here. In order for me to actually see that output, I need to print it. So I'm going to put this inside of an SOP. Right. Let's try that again. I'm going to run my program, and this time we'll be able to see the number that is randomed here in our console. Right. That time I got a 6. If I run the program again, did I just really get another 6? There's a 9. Cool. So what I would like to do real fast is, instead of hitting this play button over and over again, I'm going to put this in a loop. Right? I'm going to repeat this a certain number of times. What I'm really looking to show you is the number range. And so in order to get like a proper type of idea, you would want to do something that is like statistically relevant. Okay? For my statistics class, my understanding is that like the bare minimum number of samples that you need in your sample size, the bare minimum sample size is about 30. So what I'm going to do is plug in the syntax for a loop that'll loop 30 times, printing off random numbers, and we'll kind of see that. Now, obviously, we could very easily go higher, but that is the bare minimum. So I'm going to plug in my for loop syntax. Right? I'm going to say for integer I is equal to 0, and as long as I is less than 30, I plus plus. Right? So we're declaring and initialize our counter variable. Here's our condition, and then at the end of each iteration, we're going to increment I by 1. I'm going to tap this over to show that it's clearly in the body. I don't actually need braces because there's only one statement, right? This is a quality about control statements, and I told you that this would start happening a lot more often with for loops because the adjustment of the counter variable is actually part of the header. So we end up with a body that only has one statement, so I've omitted the braces. But this particular loop will loop 30 times. I'm going to tell my program to run, and there we see a somewhat good distribution. Right? Notice that 0 is in my set, but not 10. We could do more iterations quite easily if you wanted a bigger sample size. And still I see zeros, but not 10. Right? If I were to change my bound, we effectively change the range. I'm going to turn it all the way up to 11. And now we should still get zeros, but we see 10s are appearing. Okay, so let's talk about like making adjustments to this. Let's suppose that using the random class, I want to simulate the rolling of a 6-sided die. There's a bit of a conundrum here, right? Because the only data that I'm able to supply it is an argument that is kind of the upper bound, right? So if I did next int 6, I'm going to get numbers in the range 0 to 5. I'll just demonstrate that real fast. All right, we see 0 as a possibility, 5. I don't see a 6. And that's kind of my problem here, right? If I want to simulate a 6-sided die, 0 is not a pip, and I'm missing 6, right? 0 shouldn't be in my set, and 6 should be. So the above method call is incapable of randoming a 6. Equally wrong, it will sometimes random a 0. What we can do is take the result that's returned, the number that we get back, the output, and then shift it just by adding 1. Okay? So I like to think of the number that's in the parentheses as number of possibilities. On a 6-sided die, there are 6 possibilities. And then you can add or subtract in order to shift that range, right? So what happens is effectively, whenever I get a 0 out of this, we're going to add 1 to it. And that's how I basically get a 1, making 0 not a possibility, right? So I just take every number, whatever it is, and shift it by 1. What it means is whenever I get a 5 out of this and add 1, well, that's ultimately how we get a 6. Let's just kind of demonstrate that real fast. Instead of making a new class, I'm going to come in here. I'm going to take my object, which is Randy, tell it to random an integer, next int, and then 6. Again, I like to think about this as number of possibilities. In this number range, there are 6 possible numbers. I want to shift that range just by adding 1. And this will help us simulate a random die. Notice that I don't see any 0s, and I do see a 6. Right? So by adding 1, we're actually changing our number range. This is effectively 1 to 7, but when I start shifting, I don't like to think about it that way. This is 1 to 6, inclusive on both ends. So of note, there are different ways of expressing the exact same number range when we're talking about whole numbers. So this works by adding 1 to the value returned by the method call, right? So whenever I got a 0 out of this, I added 1, and that's how I got a 1. Whenever I get a 1 out of this, I'm going to add 1 to it, and that's how I get a 2, so on and so forth. Since 1 is added to the value returned by the method call, a 6 is achieved whenever a 5 is randomly generated by the method call. Likewise, if a 0 is random in the method call, it will become a 1. We're not going to create this rolling dice program because we basically did it, right? This is how you would go about randoming a dice. It's important to note number of possibilities, and then a shifting is applied to the result. That's going to be it for this one. I'm going to see you in the next one where we'll get started on rock, paper, scissors.